Good afternoon, everyone. I am J. Revati, Assistant Professor, Department of Biomedical Engineering, KIT, Karnataka Institute of Technology. I welcome you all to the today's webinar, Medical Device Calibration. I extend a warm welcome to our speaker, Mr. Pragadheeswaran Venkat, founder, Aries Biomed Technology Private Limited. It's my pleasure to welcome all the participants for Young Minds of India and Citizens of Tomorrow. The purpose of medical device calibration is to ensure the safety of patient. It also plays a major role in determining the accuracy of operation of medical equipment used for diagnosis, treatment, and monitoring of equipment in healthcare sector. The use of certain standards is essential for assuring the safety and the efficiency of medical devices. So the main objective of this webinar is to provide a holistic view on the aspects of medical device calibration. Once again, I welcome you all on behalf of KIT, Karnataka Institute of Technology, Coimbatore. I would like to introduce our presenter, Mr. Pragadheeswaran Venkat. He is the founder and director of Aries Biomed Technology Private Limited, Coimbatore. He completed BE in Electronic and Communication Engineering and MTech in Biomedical Instrumentation and Signal Processing in the year 2004. He worked as a service engineer in Phoenix Medical Systems, Chennai, and biomedical design engineer in Taylor Evolutics. Later, he worked in Pittsburgh as a head of biomedical R&D. During his service, he contributed his work in development of ventilator, medical air compressor, and respiratory purifier. In the year 2009, he started Aries Biomed Technology Private Limited. It's a product development firm specializing in designing and development of medical and healthcare products. They are specialized in development, manufacturing, and marketing of products for respiratory care. ABT has worked in partnership with research teams of major universities, leaders, now I hand over the stage to Mr. Pragadheeswaran.
Hi everyone, good afternoon. This is my first live session with online, so this is my first experience. Thanks for the opportunity given. Today we are going to see the medical equipment calibration. Before going to the calibration, it's a bit of a vast subject. Before that, I would like to introduce the medical devices use and safety. Before understanding why we need calibration, the essential of calibration and everything, I would like to go through the medical equipment use and safety. Okay, so you can understand why calibration is so important for the medical equipments. Okay. Before that, I would like to introduce our company. Our company is into medical equipment product manufacturing and R&D. I started this company in 2010 as a service and R&D company, and currently we are actually into research and development of medical equipments. Mostly we are into respiratory care for a long period of time, as well as we are manufacturing equipments for big companies who are actually into respiratory devices. Okay, so I will go for the presentation. Okay. Certainly, some corruption is in the PowerPoint. I don't know why. Okay, anyway. Okay, so before going to the presentation, safety in healthcare. So we are all talking about the calibration, validation, the difference between the calibration, validation, why it is required, what frequency the calibrations are required, how important it is, everything. Before that, we are just coming, going through the safety in healthcare. Okay, the importance of safety in healthcare will make you to understand why the calibration is so important. Okay. Safety in healthcare, what it says that the primary medical ethical rule says that first, don't do any harm to the patient, whether you are giving a treatment, making him okay or not, but don't do any harm to the patient by the way of doing medical practices. Okay. What it says that the medical ethical rule says that the patient must not under any circumstances be harmed or cause any unnecessary sufferings. So safety in healthcare is also given very much important to developed countries like European Union as well as in US, which they got such kind of a NPSA, National Patient Safety Agency. What it says, the hospital related accidents on the patient. Okay, this is the chart that what NPSA says, National Patient Safety Agencies. Okay, there is no such agency in India. So what this agency says from UK, the people who are getting admitted over the hospitals or coming as a outpatient to the hospitals, there are 275 patients they are dying per day, not because of their own problems. It is because of medical safety. The medical safety issues, medical safety breach, or what we can say is accidents happening with respect to different kind of equipments and different scenarios. So, example, you see this pie chart. Life support devices is causing 10% of death on patients every day. Okay, that's a contribution, right? 275 patients per day. In that, 10% of things, 27 patients close to, they are dying only because of life support devices. And diagnostic imaging 5%, in vitro diagnostic 5%, implants which is killing 23%, and disinfection monitors, drainage suction, and syringe and needles and surgical equipments 23%, and bed and mattresses 2%. You can't even imagine that even a bed and mattresses is just a simple mechanical device also kills patients every day, 2% of the patients, right? So which means that 4 people are dying because of bed and mattresses. So this is what it says. And number of reported accidents is what it says, that device is delivered with faults 32%, device developed faults after delivery 21%, user errors 15%, no established link to the devices 32%. The accidents happening into the medical equipment industry, which is where the NPSA is giving all this data from UK, where the um, stringent standards are being followed. They are saying this much of accidents are happening. Then imagine there is no such kind of agency in India, where there is no such kind of data we have in India to say how much patients in India they are dying because of this kind of accidents. Okay, so example, if you take in Coimbatore itself, Coimbatore and Coimbatore region itself, per day more than thousands of surgeries are happening. I'm not saying only Coimbatore. In and around this Coimbatore district, per day 1,000 planned surgeries and unplanned surgeries are happening. And if you consider the whole India, there may be a multiple of 25-30,000 surgeries per day. There is no established data what we have in hand with respect to safety in healthcare, which is causing how many number of people are getting into problem. The next thing we need to discuss about not only the calibration is one part of the medical safety. Okay, of course we are going to discuss a bit about calibration also, and before that we need to have certain basic ideas about like how we are as a biomedical engineers need to concentrate on even acquiring the suitable medical equipment for the hospitals, and manufacturer defects, which is what we are getting the machines in our hand, as well as initial inspection on deliveries, maintenance, where the maintenance, the calibration, which will come into the picture, and training of those equipments for paramedics and the user and even the doctors. It is also in our hand actually, and the handling and operation of the equipments. And patient monitoring. Patient monitoring, I'm not saying the patient monitor, it is a patient monitoring and its alarms are all put together. So, yeah. Types of safety, we must have studied a bit about types of safety: user safety, patient safety, and environmental safety. So basically, patient safety is more discussed about earth leakage current, which kills a patient or the user, and biocompatibility issues, wiring loose contacts, tubing connectors mistakes, operation theaters interoperability, and gas at extreme level settings, calibration problems, and etc. Calibration problems. So that we will little elaborate, right? User safety. So user safety is a majority of the threat coming to the patient side. More of the patients is dying on everyday safety related issues. The major killer is a leakage currents and gas leakages of interchange of gases and like gas leakages, where here also the calibration plays a very important role, and radiation leakages, viral element passages, work environment, human machine interface complexities, lack of awareness, abnormality through observation, and improper alarms, confirmation of inputs. Environmental safety, we basically classified as biocompatibility issues, which is we take equipment, servicing the equipment. After the service, we throw the equipment out, right? Maybe we can say that's a condemn the equipment, right? When you actually condemn the equipment, there is a proper methodology need to be followed for the medical equipment. Even a needle syringe destroyer has to be followed with certain protocol to condemn the item. Even a syringe which causes the viral element issues with respect to the environment. So those things, it's what is coming under environmental safety. Most of the medical equipments is constructed out of electronic systems. So the usage of restricted hazardous substances over the electronics PCBs, ROHS PCBs are very important. So that is what it discusses about the environmental safety and hazardous gas leakage and reusability. Okay, so let us go with the how a patient is getting killed over the hospital scenario. A simple how a medical mechanical bed will kill the patient. Okay, so you see, I'm not saying anything out of this presentation based on my own imagination. It's all based on there are incidents happens. That is why IEC standard formed a standards for the medical equipments, which is of two categories. One category is a collateral standard, another category is a particular standard. Based on particular standard and collateral standard, we adhere to test and validate and calibrate the equipment. You got it right. Now we'll go for the safety issues with the mechanical. A bed rail, a simple bed rail. Um, can you imagine that a simple bed, hospital bed, or any bed? No, we use in every home we use a bed, right? So it's not killing us, right? Every day we are we wake up, right? But in hospital scenario, how this happens, right? So this is what it says in UK. As per NPSA, is like 100 patients of excess, they are dying per year as a result of bed rail entrapment. So sorry, the picture has got corrected here a little. The bed rail entrapment. Okay, the thing is that this is where the medical equipment importance coming into the picture. Okay, the design and calibration, or whatever I can say, the safety issues which is coming into the picture, because in hospital beds are coming out with rails, multiple of rails. Okay, the patient is going to be placed over the hospital bed. He is not in a normal situation. He is actually placed over the bed in an unconscious state. He may be sedated or partially fully sedated or partial sedated. So he may get into a trap into the bed, and he may get into kind of a excitement, or he may get into kind of a unconscious this thing. He will go and get entrapped over the hospital rails, which kills the patient. So that is one. Then that is one typical scenario which explains how we need to design a medical equipment, even if it is a simple mechanical bed, to a very complicated defibrillator and dialysis machine and a ventilator. Okay, so this is a very simple this thing. What it says is 2% of every year, 2% of people are dying only because of hospital beds. And another thing, there is another example. There is a operation theater table, right? The patient is placed over the operation theater table. Usually, in operation theater tables, the patient is lying over the operation theater tables in a naked condition, right? So sometimes it crush the patient toe, and sometimes the blood will ooze out of the patient, which will cause the condition which kills the patient. Got it, right? So this is one typical scenarios where how important how important the medical equipment plays a very vital role. Okay, so there are multiple of scenarios are there, like patient killed on the operation theater, x-ray monitor broke and fell during the examination, elderly patients fall over to the ground, newborn baby falls from the weighing scales. These are all the typical scenarios happen. Based on the typical scenario, the incidents happened is what is actually presented over here. The majority of the user related safety which comes to electrical safety, patients are often placed over the vulnerable situations, are also the staff uses a defibrillator kind of a shock delivering equipments. Okay, the patients are subject to electrodes or direct contact with the heart. So we are classifying the device into two things. One is a macro shock, another one is a micro shock, right? So the macro shock, we all know the macro shock, which is the shock of 230 volt with a higher ampere rated current, which directly pass through our heart, which gets a 100% fibrillation and kills the patient. So macro shock, most of us must have experienced in a normal situation, where we sometimes touch the electrical live wire. It directly passes through the human body, and that will fibrillate the heart. So the magnitude of current which is passing through the heart is very high. Sometimes it paralyzes, or sometimes it is actually burns the skin or something like that will happen. And if you see this chart is a very important chart to every biomedical engineer to understand what is the current which kills a patient over the threshold level actually. Okay, so if you see this, always the current which is killing the patient is not the voltage, is only the current, the excess of current which will kill the patients, right? So if you see that 100 milliampere, 1 ampere, 10 ampere, 100 amperes. Okay, the ventricular fibrillation happens at close to around 100 milliampere plus. That is where we need to understand there is two things are there: micro shock and macro shock. Here you can see one typical scenario here, the electrical closed circuit, where this is a defective device, is nothing but a medical equipment which is not performance calibrator, which is the paramedic is touching the equipment on the body. She gets an electrical shock because the device is not connected properly with the electrical socket wire, which is a ground conducting wire. Okay, so she gets a all leakage current. We have to understand what is leakage current here. The leakage current, the leakage current is the jumping of excess electrons from the equipment's body. Okay, so that's, see, the every equipment is connected with multiple of boards. Anybody cannot make a medical equipment or any equipment without a leakage current. Any equipment which gets connected to the AC mains power will have some kind of a jumping of electrons. Okay, that jumping of electrons from all the boards, capacitors, and insulation materials, power supplies, those transformers, those cumulative current which will which will come out of the board, which requires to be eliminated out of the machine. Okay, that should be a proper way out for the leakage current. Every equipment, it has got a proper insulation. Medical equipment, I'm saying, every equipment has got a proper insulation, and we used to follow certain insulation standards which will collect all the equipment leakages, which is of magnitude of close to around 100 milliampere, that terminated to the electrical main earth wire, so that wherever the least resistance path is there, that follows a least resistance path to get a drainage, right? The leakage drainage, we call it as leakage drainage. Then the patient who's touching over the machine, he will not get the current. Okay, so that, or it will be minimized. Okay, say example, in this condition, a bad earth connection. The bad earth connection is a broken connection where there is no way path for this equipments to give all leakage current to the earth line. So all most of the current passing through the human body, which we call it as micro current. Why it is killing in the patient? Because micro current, what I said is macro current, it is a 230 volt. Micro current, it may be of magnitude is only 60 volt with 100 milliampere or 125 milliampere or 200 milliampere maximum. Okay, what will happen is the current, it is actually which passes through the equipment through the electrodes connected over the patient with the gel electrodes which brings the patient body impedance to the minimum in the sense like few of milliohms or ohms, right? So what will happen, the magnitude of current passing over the patient, which increases, which causes the more of a leakage current, which gets into fibrillation of heart. Okay, so this is what we need to, before understanding the calibration, we need to understand what this symbol says. Every medical equipment, if you see, you can see this kind of a classification of medical equipments. Every biomedical engineer should understand what this symbols implies. It's very important to understand. It says that two things. One is type of an equipment and class of an equipment. The type of an equipment which determines how much leakage current it is designed for, how safe this machine to be used over the patient. Okay, if you see this, the man, just a man, a simple man, there is no electrodes, nothing. If this symbol is there, which is called either a type B equipment, we call it as type B equipment. If you see this symbol on a medical equipment, what it says that this implies the machine connected over the patient is got a minimum priority for leakage currents. And with this particular symbol equipment, the patient who's connected over this equipment can be defibrillated. We can apply the defibrillation over the patient. The leakage current which is on equipment body as well as the power supply contact points, it is going to be of little higher than the other classification of equipment like a BF and CF equipments. So this is a very basic type of medical equipments which allows more leakage current to the body of the equipment or to the patient side. More of this equipment is of the plastic body is going to get connected over the patient kind of equipment. So this is typically coming for medical air compressors, or which is nowhere the patient is going to get connected, or kind of equipment like suction apparatus. Those kind of equipment, this type B will be allocated. Type BF, we call it as type body floated. These kind of equipments which has a reinforced insulation on a power supplies, which reduces the leakage current over the patient. The type B of equipment also, you can apply the defibrillation on a patient. So this is also safer medical equipments to be applied over the patients. The more critical type of equipments, which is like a defibrillator and a ECG machine and a pacemaker kind of equipments, which comes out with a CF type of symbols, which is called cardiac float. Okay, this got a very minimum allowable leakage current to the patient. Cardiac float, when you can see two type of cardiac float. One type is with just a heart with a dabba. This says that this has got a reinforced insulation. It operates on the AC as well as DC, as well as it is also can be applied over the defibrillator. So nothing will happen to the machine, nothing will happen to the patient also. Class 2, which is a zero leakage current, almost like 0 nanoampere leakage current will come out of the patient to the patient, because this particular equipment is double insulated, reinforced insulation provided based on a basic insulation. So this is a pakka medical equipment, but you cannot design an equipment only on a class 2, because all equipments cannot be designed on a class 2 application. Always there will be a AC power supply connected to the equipment which charges the battery and applied over the patient. Sometimes we use the equipment both on AC and DC power supply. Class 2 is fully battery powered equipment. That is what is class 2, but more of equipment like a Holter monitor kind of equipments which will come into class 2 kind of application. Now, so we understand that the electrical symbols and the leakage current allowed to the patient side of it. Now, we understand that how important the medical equipments, even a bed rail, entrapment, simple mechanical beds will kill the patient. How the user safety is very important to be on a patient side of it. Now we will come to the calibration. Patient safety. When it comes to patient safety, calibration is it's one part of the job of a biomedical engineer to ensure the equipment going to be applied over the patient is got a safety and accuracy. That's the explanation. There are a lot of confusions over why the calibration and validation, the difference between the calibration and the validation. The calibration division in the hospital, right? They got multiple of equipments: electrical safety tester, performance calibrator, and leakage current tester, and what else? Flow analyzers, multiple of things. The calibration is a process. Clearly understand, calibration is the process, is just to ensure the set parameters delivered with the tolerance. We are just ensuring, and example, you take a ventilator, you are just ensuring a set value is 500 ml tidal volume. I'm getting 475 ml tidal volume, which is acceptable range of measurement. That's all. It is not meant that the equipment is going to correct anything for the end equipment. EUT, we used to call it a equipment under testing, EUT. Okay, so the equipment of the process of calibration is only to assess the set value delivered as per the tolerance. That's all. It is not going to get corrected. The equipments are not made to correct the EUT, because the EUT which will come from the different manufacturer. That is the first thing we have to understand. Okay, calibration and a validation more or less the same, but calibration we are ensuring and we are making the sticker out of that, and we are saying that this is validated, so this is calibrated with my actual equipment, the tester. The tester is 10 times more accurate than the equipment under testing. That is why whenever the calibration process begins, we used to have a calibration certificate of a calibrator. That is very important to understand. We used to call it as traceability certificate. Say example, the traceability certificate, which means that every year or a frequent manners, we need to send the calibration instrument for the calibration. That equipment will go to a particular standards testing protocols, which will say this is got a accuracy level of plus or minus 1% or 0.5% or 2%, and your EUT is plus or minus 5%. So this you are going to give a validation certificate or a calibration certificate for your end equipment based on the calibration equipment. That calibration equipment is going to get a traceability from the master equipment. The master equipment is a different equipment that will have a few times of additional calibration or accuracy capability with the actual calibration instrument. So this is a process. Okay, in the validation, what we are saying, validation is very simple. Validation, it may be at everyday purpose we used to do every day. Sometimes, every operation theater, every other major surgeries, we need to have validation to be done. Example on a FiO2 monitor. The FiO2 monitor, which is see, the majority of accidents in the hospital theaters happening with respect to majority of accidents happening over the operation theater. Why? Because there the patients vulnerable to more of a leakage current because he is in 100% unconscious state. There is a complexity of equipment used in the operation theaters are very high because we use infusion pumps there, anesthesia ventilator there, ETCO to monitor there, patient monitor there, suction apparatus there, electrocautery unit is there, and operation OT lights are there, multiple of different combination of equipments, pneumatic, hydraulic, and all that. So the vulnerability of accidents is more in operation theater. That is why more number of patients are getting killed in operation theaters. So the frequent validation, I'm not saying the calibration as per the protocol of universal IEC standards, it says that every once in a year you have to do a calibration of a equipment and get it ensured of the delivered values. That's all. If the calibration is not passed, the manufacturer to come and assess the issue, maybe he has to change the sensor, he has to run some protocol to make the accuracy to come out to that level. Otherwise, the fail means it's failed. Calibration instruments cannot make your end equipment to pass. It will only tell you whether it is okay or not. In operation theaters, kind of a vulnerable areas where we need to have a validation instruments. Validation instruments may be a very simple gadgets which will tell you, okay, every operation after the FiO2 monitors, most of the hypoxia is a main problem in operation theaters because the people used to keep on changing and there are gas combinations used to change the frequent. What will happen is uh, they need to do a validation of equipment if every once in after operation. That is a certain big hospital they used to follow. Every other surgery is completed, there will be a fumigation procedure, there will be a validation procedure. So validation instruments are different, calibration instruments are different. By using a calibration instrument you can do a validation, but validation instruments may be a different equipment where that is low cost equipment also. Okay, so that will be used in frequent application in all the areas, right? Only in a very critical areas. And also, who's forming this? You have to calibrate with this tolerance, you have to you have to validate with this tolerant, and you have to calibrate with this tolerant, the frequency of calibration and everything. It is all determined by the international standard quality management procedures. We used to say IEC standards. IEC standard, International Electro Committee or Electromedical Committee, which is forming these standards for medical equipments. That has two kind of standards. One is a particular standards and collateral standards. All the biomedical engineers to understand this very important. The IEC standards are two classifications. One is the basic standard or collateral standards. Another one is the particular standards. Collateral standards are applicable for any equipment. You manufacture equipment, you are using equipment, or you are servicing the equipment, anything like syringe needle destroyer or a suction apparatus or a ventilator or anything, any XYZ equipment, the collateral standards are applicable. Say example, you are making an X-ray machine, or you are buying X-ray machine, or you are using X-ray machine, and you are servicing the X-ray machine. You have to follow the collateral standards, which tells you certain standards. I say example, there are certain standard IEC 60601 1 2, which talks about electrical safety of the X-ray machine, electrical safety. So it which is coming under any equipment, suction apparatus also, you have to test and paste this particular symbol over the equipment. Say example, I'm making a X-ray machine. X-ray machine, obviously, it is no electrical contact with the patient, right? So we will go for type VF equipment classification. This says that 110 milliampere of current over the body is allowed, right? So IEC standard says that 60601-1-2 says that we will follow to a medical equipment calibrator from the Fluke or some Reigel medical, which is an electrical safety tester. We apply over the equipment. You measure the user touchable part and the insulation parts, which will tell you what is the value of leakage current is over the equipment. If it is within 110 or 120 milliampere as per type BF, this is passed. Okay, so that is why I'm saying, before understanding the calibrators are two types. One is the performance calibrators and safety calibrator. Any equipment you are taking for calibration, you have to first do the performance calibration. Once the performance is tick, then you have to do the safety calibration. The safety calibration is also tick, then you are qualifying the equipment. There are a lot of mistakes are happening over in India. There are a lot of people doing calibration. They are only doing performance calibration. They are just taking the ventilator, applying the ventilator on the Fluke or Reigel gas flow analyzer, Citrix gas flow analyzer, or Aries gas flow analyzer. They are just applying over it, taking the values. I set 500 ml tidal volume. My delivered is 480 ml tidal volume, and certain RR and other parameters. Tick, it is passed. No. Once you pass the performance calibration on equipment, you must do the safety calibration. When you are approaching for the safety calibration, again you have to apply your biomedical mind to say that what is a type of an equipment. Example, whatever your type of an equipment of a ventilator will not follow the same leakage current of a standard which says that type CF. But modern electrical performance testers, it has got its own protocol. If you just see, you say ventilator, it will tell you what is the type, leakage current, pass levels, everything. You just need to connect your equipment, switch on. It will do all single fault condition and tell you what is the leakage current. What is single fault condition? The single fault condition is also a biomedical engineer's very important word. Single fault condition. What it says that I am having a medical equipment. I am connecting the medical equipment to a electrical socket. The socket itself has got 23 types of problems. The socket, electrical socket, what it has got? Neutral, phase, and earth, right? That three plugs, it has got 23 types of problems. Sometimes what will happen? The combination of problem, both the sides phase may come, still your equipment works. Both the sides neutral comes and the earth line phase will come, still your equipment managed to work. And phase will be available, earth will be available, neutral is partially available or not available, still your equipments managed to work. Phase and neutral available, earth is not working, earth is not at all connected. Your equipment is pakka designed as per the insulation procedures, but earth is not there. still your equipment works. But it is called a single fault conditions. This single fault condition, the leakage currents will increase. That is where we have to be very careful. In hospitals, there are equipments, frequent failures used to happen, right? Because of electrical socket issues, the single faults, which will increase the leakage current, make the fault on capacitors, eventually the equipment will fail. So the single fault, with the single fault, whether your medical equipment, as per the classification of type BF or type CF, is passing the leakage current value. That is what you are going to test it over the performance test, safety testers. So collateral standard, what it says that you take any equipment, X-ray, ECG equipment, or a defibrillator kind of a dangerous equipment, or a dialysis equipment, or a ventilator, whatever the equipment, or even a needle syringe destroyer, a very simplified equipment in the medical industry, it will say you have to follow certain standards to test your equipment for the collateral standards. But collateral standards are very wide. If a manufacturer need to be worried so much on collateral standards, I have to pass my equipment with the IMA EMC test as per IEC 60601 iPhone 2, iPhone 1, iPhone 1, iPhone 1, iPhone 8. 8, what it says, alarms also designed as per the protocol. I cannot make simply one alarms to make a sound. It should have a dB level, it should have a flashing range, everything should be determined. Okay, so collateral standard, it says that. Then particular standard defines certain things. Particular standard just says that each and every equipment which is called a particular standard. Example, IEC 60601 iPhone 1, iPhone 12, which speaks only about ventilators. Likewise, iPhone 60601 iPhone 2, iPhone 6, so it talks about X-ray machines. So what it says that even you are having a capability to build a ventilator which gives you 3000 ml tidal volume with a pressure of, say example, 120 millibar of pressure. No, you cannot do it. You have to see that your equipment not delivering more than 80 cm2. Your performance testers used to have some protocols. Every calibrator used to have protocols. That protocol defined by the countries. Okay, say example, CE marking or CE conformity of Europe. It says that certain protocols and performance need to be tested for during the calibration as per our country law, our country classified systems. Certainly for USA, FDA is classifying that. Australia has got something else. Even China has got something else. But India is just now coming out with the standards called CDSCO standards. We're supposed to get all the standards of CDSCO implemented at this point of time. Because of COVID issue, it is getting delayed. Now, government is very serious on it. Anytime it will be implemented. Once it is implemented, the biomedical engineers with the knowledge of how to do a performance testing as per the IEC standards, calibration of the equipment as per the IEC standards, particular standards and collateral standards, we will get more opportunity in a companies who are designing equipments as well as in the hospitals. So in hospitals, what they are doing, they used to have some kind of a checklist, right? They connect the equipment. Okay, tick, tick, tick. Okay, this is coming, this value is coming. This value within the tolerance value is coming. So it's all fine. The equipment is passed, or this is not adhere to the performance. Equipment is failed. The particular equipment is not passed. Then they have to call the manufacturer. Manufacturer will come and see what is the issue, correct it. Again, we have to go for the calibration cycle, do the performance testing. Once the performance testing is passed, then do a electrical safety testing, or any safety testing is defined as per the protocol for the machine. Then pass certificate should be over the equipment. It is not that we do a performance testing, put a sticker and pass the equipment. No. That is why the calibration procedures are costlier because they have to do two procedures, and the calibration procedures are cumbersome. It is not that you do a connecting equipment and we'll give you the report, you take it up and print it out and sign it and file it. No. So we are avoiding, by doing the calibration, the electrical safety is ensured, the patient safety is ensured, the user safety is ensured, and hospital confidence, the doctor confidence over the equipment usage is ensured. And when we need a calibration, that is another question. When we need a calibration, okay, certainly as per our NABL laboratory for calibration, it says that certain equipments need to be calibrated in 6 months period of time. Certain equipments to calibrate for 1 year period of time, and most of the equipment will come in the cycle of 1 year period of time. Okay, I'm taking a calibration of equipment. Say example, my ventilator, I'm doing a calibration on my equipment with the performance as well as safety. Passed. I'm putting a sticker. Fine. The equipment is running. Say example, after 2 months, the equipment is getting into major service. The power supply is failed. I'm changing the power supply. Then, as per ethical rule, as per the ethical rule, the calibration is breached. You have to redo the calibration again, because when you are changing the power supply to the new one, or you are doing any major service on equipment, any major replacement of component internal to the equipment, what will happen after the major downtime? I'm saying after the major downtime, you have to go and redo the calibration and put a new sticker. That will be the prompt one. Why? When you are doing that, you may be changing. Say example, in a power supply, a capacitor failed. You are a biomedical engineer, a manufacturer is coming and changing the capacitor. A capacitor, what is on the equipment is, say example, it has got a effective series resistance of 1 milliohms as per the medical standards. Your service engineer comes, he is seeing that okay, 1000 microfarad, 25 volts. He is going to the market buying the same 1000 microfarad 25 volts, replacing it. But this has got 10 milliohms of effective series resistance. Because of that, the ripple will increase. Because of the ripple increase, there will be a cycle of changes which will increase the leakage current of the equipment, which causes the leakage current increase during the single fault. It's the same scenario. Some other single fault condition also is occurring. The mains power earth is drained off. In the hospital, they are not maintaining the earth. Some problem. So the leakage current is gone above 200 milliampere to the ECG machine or something, which causes the problem. So whenever there is you calibrated the equipment as per the NABL, you did it. Your next cycle of calibration is 1 year after. When the 1 year after comes, before that, if you are doing any major service on equipment, as per the ethical rule, we have to redo the calibration. That is very important. When you are redoing the calibration, again you will do the performance as well as safety calibration. So this is a thumb rule. This as per the ethical, this one we have to follow this. As per the ethical, every time when we are doing calibration, we have to do both performance as well as safety. Whenever we do a calibration, we have to understand bit about what is that the classification of the equipment says. Based on that, whether we are testing the equipment as per the classification of the equipment. This particular CF classification will not be applicable for X-ray machine, but whereas CF is very stringent, where it allows only, as per the current CF procedure, it is only allowing 600 microampere of current at the extreme single fault condition to the patient touchable user part. It is very stringent. Okay, that will not be applicable for anything else, other components, other equipment. So we have to understand. So that is where our common sense and knowledge is coming into the play. So everyone can do a calibration. See, example, if I know how to switch on the equipment of a calibrator, if it is a ventilator calibrator or a defibrillator calibrator, I can just switch it on. That will guide you what all you have to do it. You just connect your equipment, that will give you the report generation. You can attach to a report and put a sticker. But where we make a difference in the knowledge wise, we have to understand what kind of classification of the equipment, what is the leakage current is allowed, what is our country's standard for classification of leakage current is allowed, and what frequency of calibration we are doing. Is there any major services what we changed it? Based on that, we apply our common sense to do a calibration. That is where we are making the difference between the person who does the calibration without any knowledge and person who knows something about the knowledge on the calibration and collateral standard procedures. That is one thing. Another thing is the calibration and certain mistakes which is associated with the calibration. Say example, a infusion pump is a typical example I would like to say. Infusion pump calibration. Infusion pumps is a very typical life support device in a operation theater or ICU. Okay, that's supposed to deliver a accuracy of, say example, even 10 ml per second of infusion to the patient. Okay, the increase of plus or minus 30% or 20% over the period of time, it may paralyze the patient or it may kill the patient. So the calibration of a infusion pumps are very important. Okay, there is a typical mistake of calibration is in the market. I wanted to express to you. Okay, that is where the importance of calibration equipments also you will understand. What people are doing in calibration of infusion. I'm not saying everybody and every hospital, but this is a thing is also practiced. What they do is they use a pipette. It marked with values. It says that per minute, 1 minute, or per 30 seconds, per second 10 ml, 30 seconds 300 ml. So they will take a pipette and they put a tube out of that. They will see whether 30 seconds in the clock, whether it is filling that 300 ml. Yeah, this is passed. That is another wrong thing. It is, of course, 30, as per the calculation, it is passed. But as per the ethical rule, it is not. Why it is not? Because every cycle it's supposed to deliver 10 ml. But what certain machine they use in Chinese machines and all they used to do is one cycle, if it is delivering only 5 ml, they will mark it. Next ml, they will give 15 ml adjustments. I'm just telling a typical example. Adjustment, finally, at the end of the ratio, they will see to that this on a mass measurement, error percentage, when you see that, it will be on control. But if the doctor says, if he sets that every 10 ml has to go per second, means every 10 ml only should go. Plus or minus will be there. Maybe 10 ml plus or minus 0.5 ml or 1 ml is allowed. 5 ml above tolerance, those things will be captured by infusion analyzers. So the infusion analyzers are costly. People used to say that infusion analyzers that needs another kind of a 6 lakhs investment. Why should do that? Let us use a pipette. Let us fill the equipment, fuel. That infusion output with a pipette and measure indirect way of calibration. This indirect way of calibration, until and otherwise it is approved by the IEC or NABL body, it is not acceptable. Another thing I wanted to tell you. In India, the calibration procedures of any equipment, medical equipment is coming under instrumentation. Okay, any equipment which is measuring and giving values and reading values and controlling the equipment by the way of feedback, it is called coming under instrumentation, electronic instrumentation or mechanical instrumentation, right? In India, we have a very strong understanding of calibration for the industrial application equipments, pressure gauges, flow orifices, big equipments, industrial equipments, very strong protocols are there. And say example, typically Godrej and Boyers is doing the industrial calibration for years together. But for medical equipments, the calibration and necessity of calibration is only we are following for the past. Say example, the awareness and the typical requirement is coming only for the past 6 years or 7 years. Before that also it was there, but it was there somewhere. Some big hospital they used to do. Not everybody. Now NABL says every hospital should implement calibration. So there are lot many people coming into calibration without understanding what is calibration. They think that just having the equipment they can do a calibration. It's not that. Government also has a very clear protocol for doing calibration of a medical equipment, say which applies a flow, applies pressure, certain things. They don't have even a clear protocol for radiology equipments, clear protocol for ventilators. But what they say, like, you follow not NABL procedure, you follow the IEC procedure. As of now, we will bring one by one. So people used to say, can I get a NABL certificate for a ventilator? No. It may be the lab NABL accredited for industrial calibration. They may be doing a medical equipment calibration. Their NABL will be there. But for pressure, yes, you can get it. Simple measurements, FiO2, you can get it. Oxygen, you can get it. For certain other this thing, government is bringing some standards. But it is not bad that we can follow the certain protocols. That is why NABL auditors, NABH auditors for the hospital, they are very particular on traceability certificate. Traceability certificate, it says that the equipment under tested with a tester or a calibrator, it has got 10 times more accuracy level by the master equipment. So calibration, the calibrator with the master equipment is a big protocol that requires even more stringent standards. That is why in India there are very few master testers are there. Very few. Tektronix is having, TCL is having, some government bodies also having few master protocols. Okay. To be very basic level of understanding, why we need a calibration? We need a calibration to ensure the patient safety and the performance safety. And why we need calibrator instead of validators? Calibrators are 10 times more accurate than validators. Do we need validators? Yes, validators also is required. Because in a hospitals, in a typical scenario in Indian hospitals, what we people are doing is, yeah, management is recruiting a biomedical engineer. I'm not saying every hospital. Most of the hospitals now understand that biomedical engineers are required. They are recruiting a people. They are giving multimeter for managing all the equipments. How a biomedical? See, example, if you are a television service engineer, you need a multimeter and screwdriver, right? And if you are a plumber, you need to have certain equipments. But biomedical engineer is like a person who going to work on hydraulic equipment, pneumatic equipment, electrical equipment, and optical related equipments. So many things. So in that, if I'm saying no, I want every hospital to be equipped with Fluke kind of, Rigel kind of international certified calibrator, which is impossible because it is all very capital expensive equipments, right? But basic validators are required. That biomedical engineers not only require a multimeter, there are basic validators are required. Okay, Aries Biomed Technology is already manufacturing basic validators for biomedical engineers to have it. But the thing is that validators also is important, but validators cannot replace calibrators. Okay, that is why what we are doing is we are outsourcing the calibration agency to do a calibration. When you are outsourcing a calibration agency to do a calibration, you need to understand whether they are qualified to understand what is the type of an equipment, what is the standards on the equipments, and whether they are doing as per the protocol. They cannot follow the simplified indirect protocol which is not declared by the IEC to do a calibration. Okay, so and frequency of calibration is also very important. As I said, frequency of calibration is declared. If you are doing any major services, major changes, or you are doing any buying refurbished equipment to your hospital, or you are doing say example, you are buying a hospital equipment, better to have a calibration certificate by the manufacturer is better actually. That is what basically they used to say a new equipment does not require a calibration certificate for the first year, which means that the manufacturer will come out with a calibration certificate. Okay, but better to have one validation done for that. That's all I'm saying. Because the machine delivered with faults, which is killing 21% of people every year. That is what I'm saying. Every day, 275 patients dying only because of medical accidents, medical errors, not because of their own problems. In UK, then imagine India, there is no NPSA. How many people are dying because of medical errors? Our responsibility, our biomedical engineers responsibility to understand, to reduce this medical accidents. In that, calibration, validation, training, understanding the basic concept plays a vital important role. So with that, I want to conclude on this presentation. You may be expecting I will be taking class with a fluke or something. No, see, there are plenty number of videos available in YouTube regarding how you can do a calibration with the fluke analyzers, or what I can say with the this one, ventilator tester, fluke ventilator tester kind of thing. Okay, but the knowledge, this is almost like I see I involved in this calibration of work from 2010 actually. I was a authorized dealer for Godrej and Boys that time. I was doing for multiple of big hospitals in Coimbatore, prestigious institutions we have worked, and currently not a lot of people are there, but we really enjoyed working with the calibration this thing. But it is not merely connecting a equipment, end equipment under test to a equipment and doing some, taking some parameter values and marking the values. And one more thing I forgot to say, that the calibration instrument, the equipment under test, you are connecting to a calibrator. The calibrator should give a printout with the equipment serial number. Very important. It is not that I'm connecting a UT with some instrument, taking manual values. When manual values are taken, human errors will come. Example, to mark as a 475 ml tidal volume, I will mark it as 435 ml tidal volume. And if I say pass, what will happen? Value is 435, but you are saying pass. If the auditor catch hold of that, your institution will come under problem. Okay, so always used to have a printout, automatic printout. Every Rigel or Fluke which comes out with the software, you can directly connect to a software which will, you can take a printout and file it. So human intervention of marking value, mentioning output result, it is not recommended. So see to that, these are all the things you follow. This is whatever I expressed is all very basic things. Okay, so basically our biomedical engineers to understand the electrical safety, basic safety. How many people are dying in India only because of medical errors? We are responsible for make this numbers to come down. So we need to understand the basics of safety first, and international equipments are there to connect it. And we are, as Indians also, we need to see that we create our own calibration standards. Government is working very seriously on it. CDSCO standards, soon they will come out, and we make our own calibration equipments also for our standards. So, as example, we always believe, we need to depend on, not believe, sorry, we depend on Fluke or Rigel, which is all made for their country standards, their country's accuracy standards. But we need to have our own standards, independence of this thing, so that the cost of a master equipments, testing equipments will come down. And in that, Aries put forth one few efforts to make out with the coming out with the ventilator calibrators. We are selling, not now, for the past 2 years, we are selling ventilator testers, validators, basically validators, peer testers, and all that. We cannot say as a calibrator because in India we don't have standards. So we say that okay, this IEC standards is not passed. We are not taking to the international, but we say that this. I'm just telling as example. As a biomedical community, we need to come out with our own standard testing calibration instruments for India by India. Okay, so that is also very important. Uh, hope I conclude with this presentation. If you got any clarifications or doubt, or if you feel like this is very basic or something, we may see like I'm not interested to take anything on a equipment level. Equipment level on a web webinar, it's very difficult actually. I can only show certain equipment. This is equipment. We connect to this side flow, that side flow, and all that. Well, basically, it is also a brainstorming session. I would like to have. I would like to receive from your side of inputs as a question or as a suggestion or whatever it is. I'm humble to expect you questions and all that. Please. Thank you. Hello. Thank you. Yeah, quality certificates required for the equipments. It is depending on, say, example, any equipments, any ECG or a ventilator. When you are buying a new equipment that comes out with a safety testing certificate as well as a performance testing certificate. Okay. Apart from that, quality with respect to international standard, if you say that, if say example, I'm a ventilator manufacturer. If I'm doing a ventilator for the market, I need to come out with CDSCO quality certificate declared by the government body. That again test my equipment with collateral and particular standards. For that, I have to take it to lab, big lab. I have to first pass through the collateral standards and particular standards of one equipment or sample of two equipments. But I cannot qualify every equipment which is coming out of my production office, production floor. Right? For my production floor output, every equipment I will put it across one calibrator, take a basic certification of performance, certification of connect with a fluke electrical safety tester, certification of insulation and all that. I attach with the equipment, give a quality certificate saying that this is tested as per IEC, these many parameters. I will also attach my CE standard certificate or CDSCO standard certificate. This is what the quality certificate is expected for every equipment you are buying as a biomedical engineer. How to know the patient doctor is using calibrated equipment for his or her inspection. Okay, patient obviously has a very least idea of calibration or inspection or whatever it is. Say example, typically we buy home care NIBP apparatus from a surgical office, surgical center, right? Surgical shop. It is made for, it clearly says that it is a home care equipment. The tolerance level or inaccuracy level or accuracy level is very wide. You cannot give a treatment, suggest a tablet based on that. It is only a emergency validator or something like that. Patient does no idea at all, right? Doctor insist on these. At least I need a year on one calibration certificate. If he's got a knowledge, yes, whatever the reading I'm seeing on a patient monitor. Say patient monitor says that my equipment is reads on 99% of SpO2. But how you can authenticate? So in authentication, you need to have a calibrator. So it is all is a common sense, our own ethical responsibility between doctors, patient, and this thing to have it. A management of a hospital to have it. So that is why they are saying NABL is stressing on hospitals. You must have at least once in a year your equipment should be calibrated, and you should have a calibration certificate pass for every equipment. There is no other scrutiny is there. Okay. Does every country have their own calibration standard? Yes, every country have their own certification standards. Okay, so the certification standard is connected with the calibration standard in different group. As example, Australia is got its own certification standard. Say example, I passed the CE marking. I wanted to or CDSCO marking for my India. I have my equipment. I want to sell my equipment to Australia. If I take it to Australia, what they will say like, if you want to sell to my country, you need to have Australian standard of certification. There will be some changes in parameters. They will say, example, we declared 80 cms2 as a safety pressure valve relief for our particular standard of ventilator. They will say 70 cms2, something like that. There will be changes. Okay, so it is different for each and every country as per their law of the land. Say example, US, they put so much of stringent standards so that a Indian cannot go and simply sell their equipment into US. So to get a FDA, it requires so much of cost. So we are not taking that kind of a risk. So your question is very right. Every country has got their own standard of procedures. Even China is they got. What is the maximum utilization period of calibrated equipment? That is what a calibrated equipment. Yeah, your question is got to this thing is very super question. What is that developed countries law says that you are buying a ventilator, you are every year you are doing a calibration on equipment. Come what may, fifth year you have to, even though you are not pack open the equipment, come what may, fifth year a quality auditor to come and certify the equipment for the further usage. Next 2 years, after 7 years, is the equipment life support device equipment life. You have to condemn the equipment, buy the new equipment, no question asked. So in developed countries like US, Japan, kind of developed countries, the life of an equipment 7 years. During the course of life of an equipment, whether you are using on patient or not, every year you need to have a calibration certificate output. After that, fifth year you have to have a quality audit certificate. Seventh year you have to throw the equipment. The best places to throw the equipment is India. Because India is the only country, not even Sri Lanka, not even Nepal, India is the only country buying refurbished used equipment to our market. That is why now the government says that there are some restrictions they are bringing over the refurbished market into this, but it will take time. So your question is very nice question. Life of a life support device is only 7 years. But in India, the people use 12 years equipment, 15 years equipment. They do keep on squeezing. Even in our home, once your TV is problem, we keep trying to repair it and use it. That is our this thing, right? So that like that, medical equipment is also followed. But soon India will come out with the restrictions on this. Is there any other question? Do devices such as blood pressure monitor, blood glucose tester that we use in our home need calibration after certain period of time? No. This is all categorized under home care devices. For your satisfaction, you want to do a calibration, do the calibration, keep it with you. But the thing is, why this is not having any calibration, this thing, but it has got a standard of certification. It has got a particular standards and collateral standards. Anybody cannot simply make a equipment and even sell it to market for home care use. It is not that, but it is not, NABL is not insisting on calibration. For your own satisfaction, you want to do a calibration, you have to do a calibration. Say example, I buy a NABP monitor. If I feel like whatever the values I'm getting, it may have a doubt. I doubt on this thing. I have to take it to the lab for the calibration, right? But for the calibration charges is more than your equipment charges. So people who never used to do that. It is doctors also won't suggest you any medicine based on your home care equipment. It is only for the sake of our satisfaction, whether we got a high BP today, whether we got a high sugar today, we took so much of sweet yesterday night, so whether I got too much of sugar in my blood, just for the cross verification. There is no insisting, nothing. For your own common sense satisfaction, you can do that. There is no insisting on that.
Thank you, sir. On behalf of KIT Kalaignar Karunanidhi Institute of Technology, I extend warm thanks to our speaker, Mr. Pragadheeswaran Venkat, who spared time from his busiest schedule. I hope this was a very informative webinar and provided an insight knowledge about the medical device calibration. I would express my sincere thanks to management, principal, vice principal, deans, and heads of various departments for providing guidance and support to organize this webinar. I would like to thank KIT technical team for their technical assistance. I thank all the participants to make this webinar a grand success. Once again, thank you all. Hope you all have great time. Thank you.